This is the Lone Crater YouTube. We hope this video helps.
You start by isolating the footage and exporting a high-quality clip so algorithms have clean data. This reduces artifacts later. Once done, identify the blur. Is the camera moving or the subject? Next, you run a single-pass stabilization to remove global camera motion, because removing that first narrows the blur model and prevents overcorrection. Make sure to keep the original timestamps and work on a copy. This preserves the reference if you need to revert. Now you apply the deblurring core. Pick multi-frame fusion for repeated patterns or per-frame deconvolution for single, sharp events, because the wrong choice creates artifacts. Once selected, estimate the point spread function, PSF, via motion vectors or blind deconvolution. Accurate PSF equals better sharpness. Then enforce temporal consistency by blending results across a small window of frames to avoid flicker, and iterate with conservative regularization, so edges improve while noise stays controlled. Finally, you refine with targeted sharpening and conservative denoising. Use edge masks so you don't amplify noise in flat areas. Once satisfied, re-encode to a high bitrate or visually lossless codec to avoid compression reintroducing blur. If you see halos, ringing, or temporal flicker, reduce deblur strength, re-estimate the PSF with tighter constraints, and increase temporal smoothing across frames. This trade-off sacrifices peak sharpness for stable.
Thanks for watching. Consider subscribing if we helped you.